Section 5.5, the alternating series. So first off, what is an alternating series? They give us a couple of examples in equations 511 and 512. Now, here we have a definition of what an alternating series is, and there are two situations, 513 and 514. I've highlighted the only difference, that -1 is either being raised to the n plus 1, the index plus 1, or -1 is being raised to the index alone. The difference is how will the expansion begin? Will it begin positive then negative, or negative then positive? Both of these are termed alternating series, and our notation of Bn makes the assumption that the Bn's are always non-negative. The Bn's are non-negative. If you look at the lecture video posted for this section, it will go over how even indexed partial sums will always stay to one side of a convergent alternating series. Odd indexed partial sums will always stay to the other side. So even and odd stay to one side of the limiting value, and that's going to come up later on in a future video. Here is the statement of the alternating series test, AST. It applies to any series which is an alternating series, this one or that one. AST provides us a condition for the alternating series, this one or that one, to converge. What do we need? We need two conditions. Here are the two conditions copied over. The first condition says that the sequence of non-negative Bn's needs to be monotone decreasing. That's the first condition. The second condition is that this sequence of monotone decreasing terms needs to limit to 0. If you have both of these true in any alternating series, then it will converge. Let's look at an example of applying AST. Example 519, let's read over the first example series. If we investigate it, we see that it is a sum of terms where the terms are an, -1 to the n plus 1, over n squared. We want to separate out in the an the alternating part and the Bn's. When we read over the solution, we can see that they go and identify checkpoint 1 and checkpoint 2. First, they're verifying that this Bn, sequence of Bn's, is monotone decreasing. The next term will be smaller than the current term. That's checkpoint 1. To get checkmark 2, we need for these Bn's to limit to 0. Therefore, with both points checked, the given series will converge. Let's do one more example. Here is exercise 278. This is something that commonly happens. This guy here is a trig function sine, and we're evaluating on the inputs n copies of pi over 2. At pi over 2, if we draw the unit circle, we know that at pi over 2, sine is positive valued, +1, and at 3 pi over 2, sine is negative valued. At even copies, sine is 0, so they don't pop up. Thus, this is, though it doesn't look like it, is in fact an alternating series. So identifying the ANs, we then look at the BNs. The BN, and then run through the checklist. The BNs are monotone decreasing. The next term is smaller than the current term, and the terms limit to 0. Because we have both checkpoint 1 and checkmark 2, we're able to make our conclusion that the given series converges, and then here's our reason why. Fantastic.